Welcome everyone to today's webinar, Security in the IoT Ecosystem, Trusting Data at the Edge. This is an IoT Security Council webinar hosted by the Secure Technology Alliance. Hello, my name is Randy Vanderhoof, and I'm the Executive Director of the Secure Technology Alliance. And today's webinar is being recorded and will be available for playback along with the presentation deck after the webinar has concluded. There will be time at the end for questions, so I encourage listeners to submit their questions using the user dashboard on your screen. I'll return at the end of the presentation to lead the Q&A, and I encourage you to submit questions while the speaker is presenting so that we have time to organize them in advance so we can get to as many of those questions as we have time for. We can advance to the next slide. For those of you who are not familiar with the Secure Technology Alliance, here's just a brief overview of who we are. So the organization is a not-for-profit, multi-industry association working to stimulate the understanding, adoption, and widespread application of secure solutions. We provide, in a collaborative, member-driven environment, both education and other information on how smart cards, embedded chip technology, and related hardware and software can be adopted across all markets in the United States. If you see on the right side column, there's a listing of some of the focus areas where we are addressing this area of security and chip technology, including access control and authentication, healthcare, identity management, the Internet of Things, which is the subject of today's webinar, as well as mobile and payments and transportation markets. Our members benefit from participating in these collaborative efforts by having access to our training and certification programs, participating in our industry councils, receiving education and information about emerging technologies, our efforts to do further industry outreach and bring more industry stakeholders under the organization of the Alliance, some networking opportunities for our members, as well as updates on recent technology trends. The things that we do as an organization to bring stakeholders together is primarily through efforts to collaborate on secure solutions that address industry challenges. And we produce white papers, webinars like this, workshops, newsletters, position papers, and produce web content for making it available for public consumption. We also create conferences and events that focus on specific markets and technology. We have a conference coming up in just 2 weeks on securing federal identity, which is focused on the identity and security markets for the federal government. We also offer education and training programs, as I mentioned, and provide certifications for professional development and provide such networking opportunities for professionals so that they can both share their information as well as learn from others about what are the current trends in the market. And we produce strong communications through our public relations efforts, through our websites, and through contributing to social media. So if we can move to the next slide, please. The IoT Security Council is one of a number of industry councils that address these areas of education and awareness and industry networking. The IoT Security Council's goal is to accelerate the market adoption of secure IoT architectures that incorporate embedded security and privacy, and to provide a forum for intra-agency and cross-industry collaboration on secure IoT architectures. We offer business-focused discussions on best practices and implementation of IoT architectures using embedded security and addressing privacy. Provide a single organization where all industry stakeholders can network and share implementation experiences and discuss applications and security approaches, and identify and collaborate with other industry organizations to define and promote the standards for secure IoT architectures, particularly using technologies that provide embedded security and privacy. The image on the right side of the screen there represents one of the ways in which we communicate IoT security through our information portal called IoT Security Connection. And we have produced and have available several publications around the subject of IoT, including blockchain and smart card technology, embedded hardware security for IoT applications, and other resources. And we welcome you to go and visit the IoT Security Connection website, as well as the Secure Technology Alliance site around IoT security resources for further information as you may want to use that in the future. Next slide, please. So today's webinar is the second in a series of 2 IoT ecosystem series produced by the Secure Technology Alliance and our IoT Security Council. Today's webinar is entitled Trusting Data at the Edge, and it will review the security requirements for trusting and managing data collected and are stored at the edge of the IoT network, and approaches for ensuring data integrity, privacy, and authenticated access control. The first webinar in the series was held last week, and it was titled The Role of PKI in IoT. That webinar was presented by Josh Jobs of Entrust Data Card, and he explained the role of public key infrastructure, or PKI, and as it can play in the securing of IoT ecosystems. By registering for today's webinar, you all have access to the audio recordings and presentations from both of these webinars in the series. Also, there's going to be an online assessment quiz available for both webinars in the series. If you listen to the 2 webinars and pass both assessments, you'll receive a Secure Technology Alliance certificate of participation for your accomplishments. Now, if we go to the next slide, I'd like to introduce today's presenter. So Sri Ramanchandran is the VP of IoT and Solutions for G+D Mobile Security, and he also serves as the chairman of the IoT Security Council. Sri is a technology veteran with several decades of experience in communication and IoT markets, bringing deep industry experience in IP and mobile communications. At G+D Mobile Security, Sri is leading the IoT solutions business in the Americas. His prior roles include CTO of Numerex, CTO of Utilidata, CTO of Telecordia Ericsson Interconnection Solutions, and CTO of Nextone Communications. Sri is recognized as an industry thought leader and holds dozens of patents. Sri earned his BTech degree in electrical engineering from ITT Madras, India, and his MS in computer engineering from the University of Cincinnati in the USA. So if we can turn to the next slide, we'll let Sri begin today's webinar presentation. Sri?
Thank you very much, Randy, for the introduction. And I welcome everybody to this webinar. We are gathered here to actually explore challenges of the edge and trusting data at the edge. And it's becoming a more and more important issue as more businesses rely on data coming from their devices to actually do business process automation and also do a lot of mission critical applications. Next slide, please. So let's start out by trying to understand what the edge is. So not many people, or people have a vague idea of what the edge is, but what I did was scour the internet for what people think of when something is called the edge. So there are very crazy definitions, starting from anything that's not a data center is called an edge, to more focused definitions that says these are actual devices such as routers or switches or integrated access devices that actually provide an entry point into certain networks. And there is the other definition, which is based on big data, which happens to be aggregated in a cloud and which is processed in the cloud, as opposed to edge, which is essentially producing all of that data. And there is the newer terminology around fog computing and fog networking that essentially uses edge devices to actually carry out a lot of computing and storage. So as opposed to fog computing, as opposed to cloud computing, right? So these are all the various definitions of what people think of as the edge. But I think, and the reason I put these things together is so that it gives you as the audience a general idea of what the edge is. And we'll go to the next slide, please, where we actually have a more formal definition by Gartner. So Gartner defines edge computing as solutions that facilitate data processing at or near the source of data generation. So if we look at it, typically IoT devices are the ones that are actually collecting data and producing data for doing data processing either at the edge or in the core, right? So essentially, edge computing solutions involve a lot of the Internet of Things, IoT. And it can be through sensors, it can be through cameras, it can be through a whole bunch of devices that are doing various things, right? And in the newfangled enterprise, these edge computing devices or these edge devices are serving as an extension of their existing networks. So when IT managers used to think of a hard perimeter for their enterprise networks, it's no longer the case. There is no hard perimeter. It's actually being pushed out where we have these edge devices or edge computing devices or edge devices being far flung that are actually still part of the enterprise network or the campus network, but still are remote from the actual enterprise. And the way Gartner projects it is today, about 10% of enterprise generated data is created by the edge devices. And it's expected to grow very fast and very rapidly to about 75% in the next 6 years. So there is clearly a very, very rapid growth of the edge that's being projected at this point. Next slide, please. So part of the reason why the 75% increase is really important is that when so much data is actually coming from those edge devices, it is really important to start figuring out, can we actually trust the data? Or is it going to be compromised data or garbage data, right? So let's look at a few examples of what the edge devices are, right? So there are many categories of edge. There are end devices, there are edge devices, and then edge computing devices. So I put these images here, and I'm sure the audience will understand where these images came from. So they are typical home automation type devices. So there is a Nest thermostat, Nest camera, and window sensors, and so on. And then those are classically end devices that are actually sending data. And the edge devices are those that are actually aggregating the data. So they are edge IoT edge gateways, the one at the top. There are hub devices that are deployed in home automation systems. And then the third one is actually a LiDAR camera or a LiDAR system that's actually aggregating information from a bunch of different sensors into one part, right? So that's another definition of, or another example of an edge device. And then when it comes to edge computing devices, they are actually devices that take data and perhaps make a local decision. For instance, in the case of the Nest thermostat, it's based on the data, it's making a local decision to say to increase the AC, decrease the AC, increase heat, decrease heat, and so on, right? So those are, it's making local decisions. So they are really edge computers. And similarly, if you take autonomous vehicles collect a lot of different data around using sensors in and around the vehicle. And they have to make immediate decisions based on all of that data. So they're really an edge computer. And the examples go on into a lot of remote surveillance and remote management applications at this point. So a lot of them are designed to actually make instant decisions or more like reflexive decisions to make sure that the immediate action is actually taken. So these kind of set up our understanding of what the many different types of edge are. Next slide, please. So I source this report on a very regular basis. This is from Ericsson. It's called the Ericsson Mobility Report. It's a very enlightening report in the sense it has a continual tracking. It's published every quarter, and it tracks continually what the change is in the market in terms of the number of mobile connections, number of IoT connections, and so on. And what they also do is they make a distinction between what is called wide area IoT and short range IoT. So short range IoT are those devices that are perhaps connected by a short range connectivity mode such as Zigbee, Z-Wave, Bluetooth, maybe even Wi-Fi. And the wide area IoT includes cellular IoT, which involves a connection over a 2G network, a 3G network, an LTE network, and so on, right? And what it's showing is that it shows the actual number in 2018 and what it's projected to be in 2024. So if you see that, you can see a tremendous increase in the number of connections going from where we are or where we were in 2018, at the end of 2018, to where it's projected to be. And the important thing to remember is that all these are actually connected edge devices, right? So they're all part of the huge plethora of edge devices. They can be end devices, they can be edge gateways, or they can be actually edge computers. And the fact is that they're all getting connected to some kind of cloud computing or data aggregation somewhere. And so what these guys track are really the actual connections, which really imply the number of edge devices. And one of the things about the increasing number of edge devices is that, just as we showed in terms of the different types of edge device examples, is that anytime you come up with a new edge device, you're going to have the actual data from that being used for different business models, different applications, and maybe even offering different types of services, right? So the plethora and variety of these edge devices is actually good because it drives a lot more innovation. It drives a lot more services and new applications that we can all partake of. Next slide, please. So just because there are a lot of edge devices, we have to understand the value profile and the risk associated with those edge devices. So this slide is information dense. There are many things that are shown here. So there is a device value. So a sensor is a pretty low cost device, 10 euros to 100 euros, and so on up to an industrial robot, which probably costs several million euros or dollars, right? So the business value is clear from that. But when you look at the typical business value and the business risk, right? So business risk in the sense of if a sensor does not work, you just replace the sensor, and unlike the case of Boeing, if you just take a regular sensor, right? It's a small change, and what it does is it doesn't affect the overall business value as much. Similarly, if you go on to a more expensive device, such as again an industrial robot, the business value of it malfunctioning or being put into service mode is pretty high, because now it probably stops the assembly line from moving, and so that's a huge loss to the business. So the business risk associated with those devices are calibrated in terms of their value, right? But when you come to security, so if you think of security as a risk category by itself, right, you realize that security is really, especially with these IoT devices, which are put together with a chain of connectivity and data aggregation platforms and applications and all that, the actual security risk is only as strong as its weakest link, right? And so you may think that, oh, this is just a $100 device. It doesn't need much security, and you may ignore the aspects of security for that device, and that may provide the weakest link in the overall connected device ecosystem, and that may be a way in which malware gets injected. That may be the way where the entire network can get compromised. So the challenge for us as a whole in the industry is, when it comes to security risk, you really want to have scalable security solutions that can be applied to the smallest sensor to the most expensive industrial robot. So, spanning that scale is actually a huge challenge for the industry. How do we do that? So that's something that the industry has been grappling with, and it's hard to figure out a one-size-fits-all security, and so there are many different efforts that are underway, which we will talk about towards the end. But this is one of the interesting challenges we face today. Next slide, please. So till now, we've talked about edge devices, connected devices, and IoT kind of in the abstract. So I took this information out of a GSMA industry examples of IoT, and it's again just a few industry examples. It doesn't include so many more that are possible that are actually being deployed today, but it gives everybody an idea of what IoT is being used for, right? So today, if you look at the smart grid, which is the electric power grid, there's a huge effort to modernize it, and as part of the modernization, it involves a lot of sensors, a lot of remote management capabilities, and a lot of control, which was not there for the last 100 years or so, right? And so IoT is actually enabling that. And if you look at smart buildings as an example, the smart buildings have new sensors that not only is used in the case of monitoring for emergencies, but also to figure out the actual density of people, the density of other information that's out there, and so on. And what is actually not listed here is the telemedicine, which is actually a very, very rapidly growing field. We just show consumer and medical, but telemedicine, which is able to do remote diagnosis and so on, is actually a very, very fast growing part of this IoT industry overall. And the thing that we all tend to ignore is in the case of agriculture, in the case of IoT, is what they call a sleeper. I mean, there is so much IoT being used in agriculture today, using a variety of different sensors, trackers, just to make the environment. Just to make the automation of agriculture really rapid. As an example, the number of farmers with respect to the amount of farmland is actually very, very low, right? So, and the farmers are using as much automation as possible to actually do their sowing, their harvesting, their managing their livestock, as well as the entire environment monitoring. So this is a very key part of the IoT industry. Next slide, please. So this is a poll question. So we'd like the audience to respond to which part of the organization do you report into. I'll give it some time for you all to respond. Oh, that's great. So we have very few folks from the security or risk part of the operations, but there's a lot from business operations and product. That's awesome. So the product and CTO R&D teams will appreciate the technical nature of this, and I think the business operations will understand the overall ramification of what we're doing here with respect to IoT and why trusting data is the most important element of that. Thank you. Next slide. Okay, so the Internet of Things is complex. So let me try to explain to you why. So to put together a successful IoT deployment takes a lot of work among a lot of different people. So the first is figuring out the device part itself. You got to get the devices with the right capabilities. You have to get the devices with the right sensors in them. You have to figure out the whole issue of batteries, power, recharging, how it's going to be powered, and so on. Right? So as an example, this is a common example I talk about, which is banana trackers, right? So a carton of bananas coming from Ecuador. So they throw they throw this IoT device into the carton, and the IoT device is actually measuring temperature, humidity, and so on. It's got light and so on. It's measuring like 14 different things, and it's storing the data. And every time it can actually connect to a certain network, which is 2G or 3G network, it actually sends out the data, right? Now, of course, this is a self-powered device, which means it has a battery. At some point at the other end of the supply chain, they got to, recharge it and then send it back, so it then makes its journey back again, right? So there's a whole workflow is built around that. Now, the next part of it, which is the connectivity part, which is figuring out how these devices actually connect to a network to send out their data, right? So typically in homes, we use Wi-Fi or broadband. If you look at farming, the picture on the bottom left is an icon for a farm that's a smart farm that's actually having a lot of different sensors. And they use what is called low power wide area. So it can be LoRa, it can be narrowband IoT. So essentially there are a lot of sensors that are sending small amounts of data, but together they form a huge aggregation, large amounts of data. But then they need a network that is easy to get onto, easy to send chirps of data, and is also very easy to cover a large areas. So low power wide area networks are specialized in that. And then there's the traditional cellular networks, starting from 2G, 3G, LTE, and in LTE there are 3 different variants at this point. There's Cat1, which is used fairly extensively in LTE. There's a Cat-M, and then there's narrowband IoT. So all of these are 3GPP specified technologies, and they all rely on a mobile operator providing the service, or an MVNO or mobile operator providing the service. And the way to get connected is to use some kind of a SIM card that actually has the profile of the operator, and that's the icon for the SIM card shown above the window, right? So that's just to figure out the connectivity. So if you look at it, the left part of this this chart is all about the edge. It's about the device, it's about connectivity, and then the right part of it is all about the clouds and how data aggregation happens and how the actual applications are enabled. Now I show OEMs because unlike the days of old where an OEM can sell a device and walk away, and if somebody is interested in servicing it, it's up to the buyer of the device to buy into an extended warranty program before they can actually get service from the OEM, right? Those days are gone. These days, OEMs are interested to make sure that they have an interest during the entire life cycle of the device. So if a device lasts 15 years, the OEM is interested in providing software updates and configuration updates throughout the 15 years that the IoT device is around. Next slide, please. So where are the challenges when we look at this complex IoT deployment? Where are the challenges in the security part? So for the edge security, there are two broad areas. The first one is the device security itself, which is how can the devices be made secure? What are the challenges in that? And then there is what I call the data in motion, which is how does data that's being collected either through sensors or other means that are actually on the IoT device, when they get sent to a cloud or to the OEM, how do we prevent man-in-the-middle and other types of attacks so that we can make sure that the data in motion is secure all the way to the cloud and the application? So this is a key aspect of that. And so these are the two biggest challenges of the IoT edge security. And if we solve these two, then we can actually start trusting data that comes from the edge and enables us to build robust applications that are actually meaningful and where we can achieve much higher business process automation. Next slide, please. So if we don't do that, then we get these dire headlines, right? The first one is an example of a classic phishing attack, which is criminals, hack the fish tank to steal data, casino. And if you look at the broader impacts, there is the cyber attack on the city of Atlanta that is, I guess, is still recovering from that. And the most recent one was the Robinhood ransomware that took down the city of Baltimore just a couple of weeks ago, right? And these are just examples where we see the actual headlines come out. But I'm sure there are a lot of other breaches, a lot of other security attacks which don't make the newspapers, which don't make the media, but it's still sufficiently debilitating in terms of its impact on the enterprise and us as end users. Next slide, please. So given that there are all these security threats and the fact that we do not want to be part of a news headline, what is the stance of your organization regarding the security threats? Okay, that's great. So it's great to understand that your organizations are actually leaning in and making sure that the security threats are actually thwarted. So that's pretty awesome. And we do have folks who are in zero trust organizations too, which is even better. Next slide. So this is a quick thing on what the data journey, the whole data in motion actually means. So data in motion is actually a journey. So it starts from the edge device or the IoT device doing data collection. And I call it secure data collection because there are many, many cases where there have been vandalism where the sensor has been replaced with something else that essentially sends garbage data out, right, based on that. And so secure data collection is an important part of that. And the second thing is the storage of that data. So IoT devices, when they get sensor data, not all of them send it out right away. They're either caching it locally or doing some kind of processing on it locally so that they're actually sending out just changes perhaps, or it could be that they're doing some processing and sending out aggregated data, processed data up into the cloud. So secure storage is an area where the bad actors are actually using the storage element to actually actually infiltrate and create bad data to be sent up. And the sending up again comes to the next part, which is secure communications. How do we make sure that any data we send out from an edge device is never compromised and is not attacked by man-in-the-middle attacks and so on, so that we make sure that the data that is gotten at the cloud or at the data aggregation layer is actually the right data. Next slide, please. So let's look at the various aspects of edge device security itself. So one of the key aspects of IoT is how do you identify every device in the system, right? So unfortunately, the actual best practice has been kind of all over the map. So there have been cases where people use network attached identifiers such as MAC IDs or IMEIs or other information relating to the network to actually identify uniquely each of the edge devices. And unfortunately, those identifiers can easily be compromised, and so they really don't provide a good way to uniquely identify the edge device. So a uniform scheme must be come up with for each of these deployments. The second is device integrity. So how do we know that device is actually operating as planned? So is there a way to actually monitor that and to make sure that happens? And the data protection, so this we talked about before, which is getting the data from the sensors as well as securing it while it's in storage and securing it while it's being transported upstream. The next aspect is the secure management and monitoring of the device throughout its life cycle. So to maintain this stance, we have to make sure that the firmware on those devices, so on, are actually kept up to date. So we can make sure that the security stance of the device is always up to date. The last one is very interesting. So till now, most IoT devices never distinguish between what is called privileged mode and regular operations. So privileged mode is perhaps where when you go into a certain where you perform certain maintenance actions, maybe where you perform certain control actions, maybe where the device actually does a firmware update so that it can actually reboot and come up as with the new patches and so on. So the whole concept of differential access control has not been standardized within IoT devices, and this is a challenge because without having at least a common understanding of this, it leads to security vulnerabilities. Next slide, please. So I'll go into the secure lifecycle management. So it consists of three things. Secure configuration updates. So you want to make sure that the configurations that are actually deployed into the device, either from an operator who's remotely managing it, or it could be from the OEM who's actually providing those configurations are actually applied with the most security. Similarly, with the firmware updates, if there is a security compromise, then we want to make sure that there is a firmware update to actually patch that security compromise, right? Or it could be due to other new capabilities that are being downloaded onto the device itself, essentially increasing the lifespan of that device. The third aspect of it is the continual monitoring and management, right? So essentially, this means that the device has to provide some kind of supervisory outlook, right? Let's say, so there is some way to figure out if things are all working as it is designed to be, a supervisory process or a supervisory check that actually gets sent back to the operator for remote management. Next slide, please. So talking about patching is also a huge challenge because the rate of security vulnerabilities that get exposed every month is much faster than the patches that we have to fix them. And the release qualification for an IoT device may take some time because either the complexity of the test procedures, or if the organization, if the enterprise wants it to go through a certain certification, right? And the certification may be industry dependent. For instance, it may be a device used in mining, in which case it needs to be made sure that it can pass some basic safety inspections before it can actually be deployed. And in general, the deployment of patches requires a very robust OTA, which stands for over the air, or some kind of remote update infrastructure and process, so we can actually keep track of that. And so the typical enterprise CIO has a compliance matrix to make sure that all of the laptops and tablets that are issued by the enterprise are actually up to date. But for IoT, it's something that's still missing. So we need a similar compliance management for IoT. And zero-day vulnerabilities continue to be a challenge. Now, for those in the audience who don't know what zero-day is, it's because not everybody is a security expert, right? And security experts are hard to find. Next slide, please. So this is a survey conducted by IoT Institute, and what they discovered was that of the 15 skills that are needed to deploy a successful IoT use case deployment and to make it scale, the one that's hardest to find is a security expert who understands what it takes to secure the device, secure the connectivity, secure the data in the cloud, as well as secure the application. And that is one of the hardest skills to find, and is really one of the biggest challenges we face in this industry right now. Next slide, please. So the other aspect of this that I want to quickly talk about is when you have IoT devices that are actually compromised, they place a significant operational burden, right? And especially long life devices that are doing a sporadic act that actually wake up and do sporadic activity, chirp back data, and then essentially go back to deep sleep for a while based on these narrowband IoT standards. So it's hard to know if they're really operating or not operating, if there's a way to actually say, if the actual integrity of the device has been maintained or not, right? So in general, if we don't have proper remote management, and if we allow, and with lack of adequate remote management, if we allow IoT devices to be compromised, they can lead to a significant operational cost burden, because now we have to do a truck roll to allow people to go service it, and so on. And in the case of connected cameras, which if you look at it, connected camera, there's probably 1 billion plus connected cameras deployed. It's probably the most successful IoT use case that is never talked about. And if you look at that, any compromised connected camera is essentially results in a loss of privacy, right? It's a compromised privacy issue. So, which is something that we should all be well aware of. Next slide, please. So to kind of summarize what the IoT edge really needs is, the first one is the root of trust, which is really what I call as the identity management, to provide identity management. Second is to have all data encrypted between device and the cloud. So this is for data and motion security. The third is prevention of malware and rogue configurations, so that we don't have a huge operational burden, and we can make sure that the integrity of the device is maintained throughout its life cycle. And the last part is to, in case of either software errors or something else which compromises devices, instead of doing a truck roll, there's a way to remotely recover these devices. That's what I call as recovery of stranded devices. Next slide, please. A quick update on data and motion security. Next slide, please. So the data in motion, the most common thing that we call it is as device to cloud. There are two parts to it. There is a device to cloud, and the second aspect of that is data provenance. Let me talk about device to cloud. So the cloud today is being used as many different things. It's used for data aggregation. It is used for application development and application enablement. And it's also used for even for things like device management, right? So you're doing IoT device management from the cloud. And the advantage of doing these from the cloud is that you leverage a very you can actually leverage the cloud infrastructure for very scalable deployments, right? So you can start with a handful of IoT devices, you can scale it to millions, and you know that the backend infrastructure, which is the cloud infrastructure, can support deployment starting from small to very large, right? And it also future-proofs IoT deployments by allowing for applications to be removed from the device and to enable application evolution on the application side, as well as the actual device capability evolution through firmware updates and so on. So the advantages are many, but it also has a lot of security issues. Let me go to the next slide, please. So device to cloud has three problems. The first one I already touched upon briefly, which is the device identity. How does the cloud infrastructure identify these IoT devices? So to use network attached identifiers makes no sense. So we got to make sure that they have unique device identity. The second one is mutual authentication. In all of our systems that we use as humans, we use a username and password, and that username and password actually represents us, right? In the case of IoT devices, there are no username and username passwords, so we cannot use the traditional means of authentication anymore, and so we have to figure out a new way to do this. The third thing is, how do we make sure that the channel is encrypted between the device and the cloud to make sure that that we have an end-to-end encryption of the data and not piece by piece. Next slide, please. So this, so today in the industry, PKI, which is public key infrastructure, and TLS have been merged together to actually create the solution that is used to solve this data in motion, or the device to cloud security part. So it solves for all three problems, which is the identity, authentication, as well as encryption. And the interesting thing is PKI provides a chain of trust, and this has been known to scale because the web infrastructure, all of our e-commerce transactions, all of our browser transactions, browser-based transactions actually uses PKI and TLS to make sure that we have secure transactions. In fact, the lock icon on your browser really uses PKI and TLS in the background to make that happen. Next slide, please. So this is a polling question. So we want to understand what is the status of your organization's plans for IoT deployment? That's great. I like the fact that there's 13% who've deployed an IoT project and are looking to improve their security posture. That is fantastic. So that is really heartening to see that you know, security is top of mind. Let's go to the next slide. So given all of these things at the edge and the challenges of IoT edge security, what is happening with respect to regulations and frameworks and guidelines? So because of the number of high-profile breaches, many governments and regulators are exploring the IoT security frameworks and guidelines. So if you look at California with their SB 327, and then UK has their voluntary code of conduct, which they put out as a very simple guideline for all of the consumer IoT devices. And it seems to all make sense, but from the perspective of the consumer device manufacturers, they have to understand this and see what their business impact is before they adopt those. But what these guidelines actually show is that they work on very simple principles, which is make sure that security starts at the time of design or time of manufacture, that there are consistent firmware updates and security patches available to those devices. And the third thing is make sure there are no trivial ways to get in, such as a username and password, or an admin type password that actually allows somebody to interact with the device in a very easy manner. In fact, there is another industry effort called security by design, which includes software, firmware, and hardware design, and it starts with that, and is actually a pretty wide framework that has been accepted by a lot of industry players. So these are the types of things that are going on, and obviously we want to, as an industry, solve for it before we get regulation being stuck down our throat. So there is also frameworks promoted by GSMA, by IEC, and NIST in the US has actually come up with some very comprehensive security documents. So one that covers, it's almost like a survey of the various security issues. And the second one is what is what is called the IoT Security Roadmap Initiative. Next slide, please. So to summarize, the edge we've seen is very comprehensive. There's going to be a lot of devices and so on. And securing the IoT device edge and the data is paramount. And before the regulators come up with regulation, I think we need to take the framework and guidelines and then turn them into appropriate best practices so that we can actually have a very secure edge. Thank you all for your attention. We'll turn it over for questions and answers at this point.
Terrific. Thank you, Shri. That was a lot of great information you crammed into that presentation. We've got just a few minutes remaining to take some questions from attendees, but before we start the questions, I just wanted to share a few bits of additional information. So if we could go to the next slide. We have some additional, I wanted to let you know, remind you that we have the online assessment quiz after the webinar. So if you want to jot down this link, you could take the online assessment right after this, or you could wait until you receive your email that has the link to the presentation and the audio recording. Next slide, please. I also wanted to point out a couple of websites where you can get additional information from the Secure Technology Alliance. First is the IoT Security Council resources page on the Alliance website. The second is the IoT Security Connection information portal, which I discussed at the opening. And the third is that on the Secure Technology Alliance Knowledge Center, we have a number of IoT-related white papers and other resources that you can access. So let's go to the next slide. We'll leave our contact information up while we take a few questions. So the first question, Shri, is are there any existing standards for signing or verifying firmware on IoT devices?
No, not that I am aware of. There are different ways to do it, and I think different organizations tend to promote those. When I say organization, different best practices organizations, depending upon the industry, tend to promote those. And for instance, in the automotive world, there is they follow a set of practices. In the case of industrial, they follow a set of practices. So there's nothing comprehensive that's applicable horizontally. It tends to be more by vertical at this point.
Okay. And you mentioned that IoT is complex and it involves a lot of systems integration to deploy. Given that, are there things that key players in the IoT ecosystem are doing to make the edge security problem easier to solve?
Yeah, that's a great question, Randy. So when you look at the various players in this, right? So and given the complexities of the fact that security skills are hard to find, and security is a large enough barrier that people are afraid to get it wrong when they embark on this. So the players with a lot of heft, with a lot of market power, such as the cloud players, such as Amazon Web Services or Azure or Google Cloud, have kind of defined certain best practices for how to actually do the secure onboarding and the secure connections with their clouds, so that it reduces the burden on the device makers and the device designers to say, okay, now I have no idea how to design security into this in terms of software and protocols and all that. How do I get started? So they're actually taking a big part of this thing. They're playing a major role in this. And of course, there are chip makers and other device vendors who are also part of that. And my company is also enabling the whole device to cloud security also.
Excellent. Well, I see that you're at the top of the hour, so I want to thank you, Shri Ramachandran from G+D Mobile Security for today's webinar. Here's our contact information, and if anyone would like to follow up with direct questions to Shri, you can contact them there, or you can contact me if you have any feedback on today's webinar or any other topics that you would like the Secure Technology Alliance to cover in the future. Again, today's webinar is being recorded and will be available for playback along with the presentation deck after the webinar has concluded. And you'll receive an email with that link and information on how you can access the recording and download the presentation. Also, please feel free to share this information with others in your organization who are not able to participate in today's webinar so that more people have access to this information. So this concludes today's webinar. Thank you all and have a good day.
Thank you, everybody.